camera-ready rovers and orbiters are standing by to snap some pictures, so stay tuned because the closest pass.
The mission schedules for the Mars orbiters were secretly changed last night. Spectrometers were retuned and camera angles were adjusted for a target that isn't on any public manifest. That target is 3I Atlas, an interstellar object moving so fast it will pass the red planet in a matter of days. You see, this visitor isn't behaving like a normal comet. It's pulsing with light and following a path so flat it seems engineered. While scientists are sounding the alarm behind closed doors, their public-facing channels say nothing. The encounter is almost here, and the cover-up has already begun. They saw it coming. Far beyond the noise of our world, a cosmic mystery is unfolding at incredible speed. The third interstellar visitor ever detected, a ghostly object named 3I Atlas, is currently racing toward the planet Mars. It's scheduled for a flyby in just a few days, an encounter so close that every space agency on the planet should be sounding the alarm. Instead, an unnerving silence has fallen. You see, official mission feeds are going dark, the voices of astronomers have vanished from the airwaves, and a strange pattern of secrecy has emerged. This isn't just about a rock in space. The most shocking fact is the object's path. It slices almost perfectly flat through our planetary plane, a feat that no ordinary comet from the deep void should be able to manage. Its trajectory is locked in, a cosmic corridor just 5 degrees off the solar system's disk, and it's moving at a hyperbolic speed that confirms it's not from around here. To put it mildly, it's cutting through our cosmic neighborhood as if it has a destination in mind. This has many people wondering, why have the world's most powerful telescopes gone quiet right as 3I Atlas barrels towards Mars? And what happens if the truth is far more extraordinary and far more unsettling than anyone is willing to admit? The silence from the top only grows louder as the encounter gets closer. What many overlooked is that this silence might be the message itself. The object was first flagged on a quiet night, July 1, 2025, by the Atlas Survey in Chile. An automated system flagged a faint, fast-moving dot that didn't match any known solar system track. The alert went global in hours. By dawn, orbit analysts were scrambling, digging through digital archives for any earlier signs, and they found it. In the files of the Zwicky Transient Facility, a handful of frames from June 14th showed the same ghostly streak hiding in plain sight for weeks. Every new data point tightened the orbital calculations, and the numbers began to tell a story that left zero room for doubt. This was a traveler from deep space. Its orbital solution came together in just a few days. The key number was its eccentricity, a value greater than 1, which is the mathematical proof that an object is not bound by our sun's gravity. It's on a one-way trip. Its hyperbolic excess velocity was clocked at a staggering 130,000 miles per hour. But the detail that made scientists sit up and take notice was its inclination, just under 5 degrees from the ecliptic. You see, most interstellar objects, like the famed Oumuamua or Borisov, cut through our solar system at steep, random angles. But 3I Atlas was different. Its path hugged the plane of the planets, a corridor so flat and precise that its projected trajectory would thread the inner solar system like a needle. The object's path raises some chilling possibilities. Whispers in the light curve. At over 600 million miles from the Sun, far beyond the line where water should freeze solid, 3I Atlas suddenly lit up. That first spike in brightness, flagged by photometry teams in the southern hemisphere, broke every rule in the comet playbook. The thing nobody tells you is that water ice simply shouldn't sublimate at that bone-chilling distance. Yet the object's light curve rose, fell, and rose again in a pattern that didn't look like steady outgassing from a melting snowball. To put it mildly, it looked more like a heartbeat. These strange, episodic bursts, each lasting for hours or even days, gave the object a bizarre, breathing rhythm. The numbers didn't lie. All across the world, amateur and professional observers connected through late-night chat channels watched its magnitude jump by half a point, then fade, then leap again. No ordinary comet pulses like this. What many overlooked was that this wasn't just a simple flicker, it was a structured, repeating pattern of energy output. The dust physics presented another mind-bending puzzle. High-resolution images from telescopes in Chile and South Africa revealed segments of its tail curving sunward directly against the flow of the solar wind. Standard models predict that light, fast-moving dust should stream away from the sun, creating that classic, beautiful anti-solar tail. But with 3I Atlas, the tail was kinked, with dense clumps of material lagging behind and, at times, bending forward as if fighting against the sun's pressure. Spectral analysis showed a dominance of heavier, slower-moving grains, particles that should have settled back onto the nucleus or failed to escape its gravity at all. The very geometry of the tail, mapped in stunning detail, defied any simple explanation. Some scientists privately suspected strange magnetic effects, while others pointed to pockets of extremely volatile, unknown materials venting in powerful jets. But no consensus could be formed because the data just didn't fit. You can see this everywhere in the reports. Teams were stumped. The light curve, when plotted over weeks, never smoothed out. It just kept flickering. Each burst revealed a fresh outflow of gas and dust, and each lull suggested that a seal was forming over an active vent, only to be blown out again. The amplitude and timing of these pulses didn't match the object's rotation or any other known periodic driver. It was as if the object was responding to its own internal triggers, not just the sun's external heat. For observers, this meant sleepless nights, chasing unpredictable outbursts, and constantly recalibrating their equipment to catch the next surge. By the time 3I Atlas reached the orbit of Jupiter, its dust-to-gas ratio was already completely skewed. Mass estimates based on the brightness of its coma suggested that far more material was leaving the nucleus than its estimated size could possibly account for. If the object was only a few miles across, where was all this stuff coming from? This bizarre behavior was just the beginning of the mystery. The Secret Orbiter Campaign. As 3I Atlas blazed a path toward Mars, something else was happening back on Earth. The flow of information, once a torrent, slowed to a trickle and then stopped almost completely. You see, the official silence grew heavier by the day. Scientific preprints about the object vanished from online archives. Conference sessions on the topic were suddenly closed to the public. Technical notes that were once routine were now stamped with phrases like operational security and internal review only. Astronomers who once eagerly traded messages on Slack about filter choices and observation times now spoke in careful, coded language or simply stopped speaking at all. The thing nobody tells you is how quickly a scientific community can be muzzled. A handful of leaks managed to surface, painting a disturbing picture. Snippets from internal mission chat logs, a heavily redacted email chain with the subject line, "Data embargo until further notice." Even the usual beautiful raw images from the Mars Express orbiter, which normally provides a steady stream of Martian landscapes, slowed to a trickle. The data was being collected, but access was being restricted, sometimes for days at a time. Inside these quiet digital corridors, the frustration among scientists began to simmer. The most shocking fact is that even proposals to get a closer look were shut down. Avi Loeb and his circle of intercept advocates pushed hard for a last-minute spacecraft flyby. The Juno probe, already in the vicinity of Jupiter, could have been repurposed to make a pass. The answer from the top was swift and final: not feasible. They cited budget lines and the risk to the primary science mission. In one leaked Slack exchange, a project manager wrote bluntly, "Not a chance." Mission priorities are set. No Delta V to spare. The proposal went no further, dying in a committee meeting without ever reaching a public debate. Meanwhile, whispers and rumors spread like wildfire through the amateur astronomy networks. A screenshot hinted at a technical anomaly in the object's spectral signature, but the details were scrubbed before they could be widely shared. For every rumor, there was an official-sounding counter-rumor. The data was being held for a coordinated release. It was being embargoed to avoid misinterpretation by the public. But many people are crazy about these mysteries, and they weren't buying it. This is where the amateur observers became heroes. A global network of backyard astronomers in South Africa, Chile, and Australia became the backbone of the continuous monitoring effort. While the big agencies went dark, these dedicated civilians raced against the sunrise every night to log each outburst. Their Discord and Telegram channels lit up with raw photometry, spectral snapshots, and time-stamped magnitude jumps. When the coma of 3I Atlas flickered or its tail mysteriously kinked, the amateurs were often the first to spot it, sometimes hours before the professional alerts were quietly updated. They were fighting a war for information against a wall of institutional silence, but soon even their view would be taken away. Blindness at perihelion. In late September 2025, the final countdown to perihelion, the object's closest approach to the Sun, was underway. But for every Earthbound astronomer, both professional and amateur, the view was about to vanish completely. As 3I Atlas closed in on the Sun, its apparent separation from our star in the sky dropped below 15 degrees, losing it in the blinding blaze of daylight. This is what's known as a solar conjunction. The Hubble and the James Webb Space Telescopes, with their strict solar avoidance rules designed to protect their sensitive optics, entered a period of forced downtime. Their observation logs, so recently filled with urgent entries, went blank. For nearly 2 weeks, from October 29th through November 10th, the world's most powerful eyes were rendered completely blind to the interstellar visitor. Right at the moment it would be at its most active and revealing. The blackout window had begun. With Earth out of the picture, Mars, trailing just 18 million miles behind the object's path, became the lone vantage point with a clear line of sight. The entire story now rested on 2 aging spacecraft, Mars Express and the Trace Gas Orbiter. These probes were never designed for comet tracking, but their controllers, working in the shadow of the information lockdown, squeezed in every possible observation their instruments could handle. They rotated spectrometers, retasked imagers, and pushed data packets through the thin window of communication before solar interference disrupted the link to Earth. Every kilobyte of data was priceless. As this was happening, a furious debate was circling around a single stubborn question: just how big is the heart of 3I Atlas? Early imaging had capped its nucleus at under 4 miles, but the sheer mass of dust pouring from its coma forced modelers to revise that number upwards, some arguing for a core up to 6 miles across. If true, it would be a behemoth. Scenario modelers raced to map the final outcomes. 3 fates dominated the discussion. The first was fragmentation. Tidal forces from the Sun could tear the object apart, scattering debris along its orbit. The second was a dramatic flare, an explosive surge that could signal the collapse of its core. Of all the outcomes, the third possibility, survival, remains the most profound and unsettling. If the interstellar object 3I Atlas were to emerge from its perihelion passage intact, its low inclination, flyby-like path undisturbed by the Sun's immense power, theorists would face an unprecedented conundrum. They would be forced to explain not just its impossible strength, but its apparent intent. The sheer forces involved in such a close solar encounter should have been catastrophic. The gravitational tidal stresses and searing radiation are more than enough to sublimate, fracture, and ultimately destroy any known natural comet or asteroid. Its survival would imply a structural integrity far beyond anything we've ever observed, suggesting a composition or construction that defies our current understanding of celestial mechanics. Was it a fantastically dense natural object, a 1 in a trillion cosmic fluke? Or was it engineered? Many are wondering if this is all just a series of improbable coincidences, a cosmic fluke of the highest order. Science rightly demands that we exhaust every natural possibility first. But when an object from another star arrives not in a random tumble, but on a trajectory of impossible precision that mirrors a meticulously planned mission profile, coincidence begins to feel like an insufficient answer. When that same object pulses with an unnatural, non-random rhythm, the steady, unwavering heartbeat of a machine in the cold vacuum of space, the doubts grow louder. And when it withstands a journey through the brutal radiation of the interstellar void that should have spelled its doom, you have to start asking different questions. The inquiry irrevocably shifts from the realm of astrophysics to something far more significant, something foundational. The questions are no longer just for scientists trying to classify a celestial body. It's no longer about what it's made of, but rather who might have made it. It's not about its velocity, but its purpose. Why this star, this planet, this moment? Is it a messenger, a relic, or a scout? We are confronted with the chilling possibility that we are not just observing a rock, but an intention. The data from Mars is now trickling in. Was 3I Atlas just a comet or the first proof we're not alone? Let us know what you think below. Like and subscribe for more.